So the PDF.
We're gonna post it in the link in the Slack channel though.
You do that from here.
Okay.
Great stuff.
Thank you. Are you ready?
Yeah.
So I think we are covering two papers today. One is pure math, and the other one is mechanics. Yeah. So you are not doing mechanics.
We are not doing mechanics.
Yeah. So we can spend like 1 hour and a half for the first paper, and maybe half an hour for the second. We see like how we go with it. So the first question, so I think the best way to do the paper, so rather than me explaining every question to you, so it's best if we maybe answer the questions in turns. And it's okay if you don't know how to do it. We can talk about it together. So and yeah. So the first one. So we'll start with. Is there any volunteer?
But you guys have done it at least.
I mean, you
So-
it's intern, so you are
Yeah.
basically. Do you want to do the first?
Yeah, so I need to find the height first, and we will.
I'll pass this this pen.
So I need to find the height first.
Mhm.
So I don't know if this one. Oh, yeah.
So what is a trapezium rule?
It's if you draw a graph and then you go like kind of square thingy.
Yeah.
So you can find it.
Can you explain it on a graph
so-
maybe?
Like if you have like those graphs. Oh.
I just fucking.
So if you have those graphs, and then I don't know, like those one, and then if you like, you can draw like square, and then this is height.
Yeah.
So I need
Yes.
to find y value and
Yeah.
but I need to find y value.
So yeah. So integration is represents the area on the graph. So it's a way to estimate the area by adding up the small trapeziums. So
So now we can find 8 because we got formula. 8 is b minus a. B is 1/2 pi.
Yeah.
Minus a over n, which is 3. So we go 8 is
so you divide them to 3
Yeah.
sections. Okay.
so
Why do you decide to divide them by 3?
because we got 3 in doubles.
Yeah.
So I do.
Okay.
So length is 30. Wait, 30 1/2. And that is it? No.
So the first one, because the length is half pi over 6, so the first one is 0 plus pi over 6.
So it's 6.
Yeah.
And 1/3 pi.
Yeah.
So we got, now we got 3 points.
Mhm.
So now I just need to plug into x.
Yeah.
Do you want to draw everything?
Yeah, so I'll get it. Do you understand what she did? Okay, so if we see, so if we say the function is like that, like some random shape, and you divide this, so to calculate the integration from 0 to half pi, it's basically to calculate the area. So we divide the area into 3 sections, and each section is like a trapezium. And How do you calculate the area of the trapezium?
You integrate it.
Oh, like in
height time.
yeah, so height
Yeah.
times height times. So like this shape.
Yeah, it's the like length.
So
minus-
base plus
yeah.
So this plus that one, right? Base plus top divided by 2. Right? So what is so it's basically this plus that times the h divided by 2. So how do we find that one? How do we find this? How do we find the length of this?
Well, last time I went for it, it didn't work out. But
How do we find the length?
So because now we have the equation y equals 1.
Yeah, so this is just f0. So when you plug, so we say fx is equal to ln x, ln 1 plus sine x. So the length of that edge is just when x is 0, right? Because this is the y-axis, and this is so this is when x is equal to 6, so pi over 6, and etc. You can find all the length of all those edges, and for each trapezium you can calculate the area. So and then you add 3 together, so you get an estimation for this integration. I'm not gonna calculate the exact numbers as long as you know how the method works. So the second question.
So we have u equals 1 to the power of x, and we need to write this in terms of u. So what I do is I divide this by 4 to the power of 2, and then I get 4x plus 4 to the power of 2 divided by 2 equals 4x, and then I can write that in terms of u. Got u plus 16 divided by 16 equals u, and now I can rearrange that. So again, in the end, I can take that 16u minus 1 is 15u equals 16. So then I have the value of u. And once I have the value of u, I can plug this. So now I know, so that's u, and then I can plug it into here.
Yeah, so so 4 to the power of x is equal to 16 or 15. Yeah. That is, yeah. You got it. If you have any questions.
No.
This was an easy one.
Yeah, I was thinking like I wish I got this one. There. So for this one, the curve of the equation y equals cos x cos 2x. Find the coordinate x on the stationary point of the curve in the interval of 0. Whatever that means. It says give the answer to the correct one. So wait. X cos 2x. Find the coordinates of x to the stationary point. Why not?
So what does this question ask you to find?
It's asking you what the. It's asking you to find the x coordinates.
Yeah, of
the stationary point on the curve.
So basically, it asks you to find the stationary points of this function. So what is the method for finding stationary points?
I forgot.
Calculus, something in the calculus. the maximum point and the minimum point, and the point fraction.
So then, I want to say you want to differentiate it, but that's not right.
Yes, yeah, so yeah.
Yeah, okay.
So if you have a function y of x, so the differentiation of y respect to x when it is equal to 0, you get the stationary points. So the way of finding the stationary points is basically you do the differentiation of y first, and you equate it to 0, and you solve the equation and you find what x is.
I think I know what you mean.
Yeah, do you remember how to find? Do you remember how to find stationary points? So what is a stationary point? What is stationary point?
I don't remember at all.
Is so if you have a function, so if you have a function like that, the stationary points correspond to the maximum and minimum.
Okay.
So here at this point, for example, the maximum. So before this maximum point, what is a gradient? What is the sign of the gradient? Is it positive or negative?
It's positive.
After this point,
Negative.
negative. So at this point, the gradient changes from positive to negative, which means at this point the gradient is equal to 0.
Yeah.
What mathematical form represents the gradient in calculus?
Well, I'm
the differentiation. Differentiation of this function is equal to the gradient.
Yeah.
So at this point, the gradient is 0, which means the differentiation of this function is equal to 0. The same goes for the minimum point. So to find the stationary points, you need to find where the differentiation of the function is equal to 0.
So then it's just to differentiate the cost.
Maybe you want to start a new page.
Yeah.
Yeah.
Hey, can I have your phone machine quickly? So then just to integrate.
Differentiate.
Sorry. Yeah. Of cos x and cos 2x, right?
That's y. That's not the differentiation. So this function is y. So you are differentiating this function.
Yeah. Sorry. It's just I need to write it out to think of it. So the integration of that it's not y. It's when you integrate cos, differentiate cos, it becomes a sine, right?
Yeah.
Yes, sine.
Does the sign change?
Sorry.
Does the sign change?
Yeah, it becomes a negative sign. Yeah. Sine x times cos 2 squared. So negative sign again.
Okay. So what? How do you differentiate? So how do you differentiate a function? How do you normally differentiate? So if I say fx is equal to ux times gx, so fx is equal to the product of two functions, like in this case. How do you normally differentiate fx? Does any of you know?
Chain rule.
What? Yeah. So chain rule. So you differentiate. So this equals to the differentiation of ux times gx itself, plus the differentiation of gx times ux itself. So in this case, how do you differentiate this function?
So then you would just differentiate it, so it would be negative sign. So negative sine x, right, times cos 2x, and then you need to plug that into that, right?
Yeah. So So you differentiate the first function, which is cos x, times you get minus sine x.
Yeah.
Times cos 2x, and next you need to differentiate the cos 2x, right?
Yeah. So that would be equal to.
So it's not equal. It's the next term.
Yeah. Cos becomes
Cos 2x. The differential. What's the differentiation?
negative sine 2x.
Yeah.
Times cos x, right?
Yeah. So you got a negative, right? But you're missing something. So the differentiation of cos 2x will differentiate it. You need to differentiate the inside as well.
Oh,
so
yeah.
the 2x
becomes just a 2.
Yeah, so it is equal to minus 2 sine 2x. Oh no, so
Yeah.
So you get
Yeah.
So the differentiation of cos 2x is equal to minus 2 sine 2x, right? Because first you need to differentiate the cos 2x, and then you need to differentiate the 2x to put in front of the. So the whole function now becomes. So now the differentiation of the function becomes minus sine x times cos 2x minus 2 sine 2x cos x. Yeah. Do you know where it comes? Do you not know how to do this differentiation? Do you know where it comes from?
Yeah.
Okay, so and now to find the stationary point, you need to set this up. You need to set this equation to 0, right? Because to find stationary point, the differentiation is 0. So minus sine x cos 2x minus 2 times sine 2x cos x is 0. Now, how do you solve this equation? Does any of you have any idea?
You can write it all in terms of sine. So if you rearrange the cos 2x.
So maybe.
So minus and this time.
Okay, so if you do this, then immediately you'll say that you'll get a cubic equation, right? Because when you times the sine x by the sine squared x, you get a sine cube x, which is very difficult to solve.
Is that not to the power of 2?
No, it's cos 2x.
Then you can use the double sine formula. Right?
What do you mean? So, but no, the cos 2x is equal to 1 minus.
But is this cos to the power of 2?
No, it's cos 2x.
In the angles
Yeah.
So then I can write that as 1 minus 2 sine theta, 2 sine 2x.
Where does this come from? Oh yeah, you're right. Yeah, but it's still the same problem. So when sine x times the sine squared x, you get sine cube x. How do you think get out? That's the easiest. I think the easiest solution. So there are different ways of solving this. I mean, so from here you might be right. So there might be a way to solve it, but it seems a bit complicated because you have a cube here. So I think the easiest way is you divide all of them by cos 2x cos x. So and then you would get tan. You would change. So you would cancel this cos 2x and you would cancel this cos x. So what you get is minus sine x divided by cos x minus 2 times sine 2x divided by cos 2x. So you want to cancel the cos, cancel it out. And here you get minus 10x minus 2 times 10 2x is equal to 0. And now it seems much easier because you only have 10, so you don't need to change sine to cos or change cos to sine. But the only thing is that you need to change this 10 2x into 10x. How do you do that? Because you just want one variable to solve this equation, right? So you want to change this sine 10 2x to the 10x.
The double angle.
Yeah, so what's sine 10 2x?
So 2 tan x.
2 10x.
1 minus tan squared x.
Yeah. And now everything is 10x. So you can see that 10x is the only variable in this equation. So you can solve the 10x. It's now it is just a quadratic equation. So minus 10x. Let's start a new page. So now it becomes minus 10x. Minus 2 times 2 10x over 1 minus 10 squared x equals 0. So do you know how to solve this equation now? So minus 10x minus 2 times this function. So I think the easiest is to say that 10x is equal to some variable u. So the equation now becomes minus u, and then we can solve this one later on. So we solve this first. Minus u squared equals 0. Is this one much easier? So how do you solve this equation?
Well, first just move the u minus u to the
You move this one to where?
other side.
Okay, so you get this.
Yeah.
And so this is the 4 because 2 times 2 is 4. And
Just multiply that by the bottom by the u.
so that's
you
equal
have-
to u minus. Yeah, so this is still cubic. But it's solvable because
Because you can take. And then
you can take a u and then it
Yeah.
becomes, and then you put this
Yeah.
on the other side. So you get minus u cubed
plus
Plus
5u.
equals 0.
And then you can take a u out.
Yeah.
Well, you can take a minus u and it becomes even easier.
Or you can just times minus 1 both sides.
Yeah.
Minus
U
5.
squared.
And then you can solve that one.
Mhm.
And then you solve the u. So u is equal to some number, and then 10x is equal to u is equal to some number, and then you can do the 10x is then equal to the inverse of 10 of this some number. So you can calculate x. Do you understand? Do you know how to do that question now?
This question?
Yeah.
I think so.
The next one.
The
The next paper.
Okay. Yeah, so basically question 3 you need to so to find the stationary point you need to find when the differentiation of the y is 0, and then you just solve that equation. Yeah, so question 4.
So I need this formula, right?
Sorry.
Like the R formula, you got A and B and then R equal.
Yeah, so you need to express the left one in terms of the right one. So I think the easiest way is to first change the r sine theta plus alpha into the left hand side, so like backwards. So what is r times sine theta plus alpha? What is the identity for sine? So what is the general identity for sine theta plus alpha? How do you split the theta and alpha? So write it in, how do you write sine theta plus alpha in terms of sine theta and sine alpha?
Is it just like r sine theta plus sine alpha?
Not quite.
Sine theta cos theta.
Yeah, so
Sine theta cos alpha.
so sine theta plus alpha is equal to sine theta times cos alpha. Yeah.
This one, okay. Yeah.
So can you first expand the r sine theta plus alpha to expand the expression?
Okay. Is it like someone told me I can do like another way? Is it that I can do it for I can use for something or not?
Sorry. Oh, this one. Yeah, you can use it. It's just a different method. Yeah, so that is so this is the formula. So, but do you know where it comes from?
I guess like from this equation.
Yeah. So if you write, so if you expand the r times sine theta plus alpha, and see what you get.
Okay. So what is it? So sine a plus b. So theta plus alpha. It's going to be, is it sine theta cos alpha plus?
Yeah.
Sine
Sine alpha
plus cos
Yeah.
theta.
And you don't forget the r in front. So because the expression is r times.
So yeah. Sine theta.
And you have an r here and r here, right?
Yeah.
Okay. And now, because the question basically asks you to change this one into that one, right? So it's basically you to equate this with that. Yeah. Right?
Yeah.
You see what I mean? So the method here to use is a equation of by equating the coefficient. So the first term you have here is r times sine theta cos alpha, right? Which corresponds to that term. Right? So if you take out sine theta, what you're left with is a 3 here and r times cos alpha here.
Yeah.
So which means 3 is equal to r times cos alpha.
Yeah.
And the same for the second term. Which equation do you get for the second term?
Divided by both.
Yeah, so what do you get?
So r sine theta equals 2.
So r sine alpha is equal to
2, yeah.
So you have two equations now,
Yeah.
two simultaneous equations, and you can solve
Like alpha.
and two variables. So you
Yeah.
can solve if you do that. Okay, so yeah, so as we said, by equating the coefficient, we get 3 is equal to, so this term, comparing this term and this term, 3 is equal to r times cos alpha. and this term, that term, 2 is equal to r cos. So 2 is equal to r times sine alpha. Okay. So to solve this simultaneous equation, there are a few ways. I think the easiest way is to divide 1 by 2. So divide 2 by 1, and you cancel out the r. So you get tan alpha is equal to 2 over 3, and you can solve the alpha. And then you can substitute it back to get the r.
Okay.
And do you know understand? And in the end you get r alpha is equal to 33.69 degree, and r is equal to root 13. Okay.
Yeah.
I think this is the easiest to think. So just by expanding this expression and equating the coefficients and solving this simultaneous equation. So you get root 13 times sine theta plus 33.69 degree. Yeah. So the next part of the question is to solve this equation. So we already worked out that this is equal to this. So this is basically this is equal to 1. So sine theta plus 33.69 degree is equal to 1 over root 13.
Yeah.
And so this theta plus 33 is equal to the inverse sine 1 over root 13, and you can calculate it from there. Yeah. Do you know how to do this question?
Yeah.
Okay. Question number 5. Is it your turn?
Okay, so it says that the circumference of the circle, 2 pi r, is equal to the perimeter of the shaded region, which is AT plus BT plus arc. Is that r theta?
Plus, so the shaded region, so AT plus BT plus AB, right? The arc AB.
Sorry? Yeah, so, and the arc AB.
Yes.
So, what I can do,
So what's theta?
theta is, so theta equals 2x.
Yeah.
Where theta equals 2x. Okay, so now I can rewrite this in terms of, so r equals 2at because they're the same length, and 2xr. That's 2xr. Now, to find at, I can do that. And I can, this is equal to x. And this length at equals
So in the
x times r.
Yeah.
So then, how do I scroll down? So then I've got 2 pi r equals 2r tan x plus 2xr, and now I can cancel out the 2r's, divide by 2r, and I get I equals tan x plus x,
Yeah.
and then I rearrange
Yeah.
that, and I get that.
Yeah.
Okay, so next one.
Okay, so if verify by calculations. Okay, if I put in the calculator, if I just put in the values 1 and 1.3, I'll have the change of sign.
What
So I'll have one will be positive and one will be negative.
what will be positive and what will be negative? Is it tan x or tan x plus x or pi? What will be?
The value for x
Yeah, but
will be either
no,
positive.
so the value for x is 1 and 1.3, right? And you put in
Oh,
and you calculate. So what do you calculate?
we're calculating. Whatever. So if I put in 1 here,
Yeah.
tan 1 equals pi minus
Yeah.
1. That value will be either positive or negative.
What value will be positive? Is it tan
The
x?
inverse
Is it
of
positive? So
No.
okay, so the equation is oh.
Yeah.
So the equation is tan x is equal to pi minus x, right? We can rearrange this equation and it becomes tan x minus pi plus x is equal to 0. Right? To solve this equation is basically saying that this function has a intersection with the x and to find the intersect. Right? So we define the function fx as tan x minus pi plus x. So maybe the function looks like that, and this is an intersection here. So before and after there's a change in the sign. So if you can prove that at this point it's positive or negative, and at the other point is the opposite sign, so it means the sign has changed. So which means as long as this function is continuous, which this function is, right? There must be a intersection between this function and the x-axis. Do you understand? Okay. So if we put 1 here, we get tan 1 minus pi plus 1. And if you put it in your calculator, this is equal to a negative number. And if you put 1.3, this function becomes 1.3 minus pi plus 1.3. And you get, which means from 1 to 1.3, there's a change of sign, which means between 1 and 1.3, the function passes through the x-axis. So there is the intersection between the function and the x-axis between 1 and 1.3. So there must be a solution as long as the function is continuous. Okay, any question on this? Any question?
No.
So the last one. So the last one is very easy. So you just try. Do you know how the iterative formula works? So you just put 1.2 maybe. So just pick a random number between 1 and 1.3, maybe 1.2, and you calculate this, and you calculate it as 1.15, and then you put it back again and you can recalculate until you get a value that is consistent to the 2 decimal places. Next one.
Here you go. So, just in substitution here, please show that. Okay.
So this is just to change. So you have the x.
Yeah.
You just try to find a way to change all the x into u.
Okay, so first of all, the bottom part of the entire thing is just becomes u
Yeah.
plus. So that's u. So then u is equal to 2x, and then 2 minus square root of x, and we have square root of x, which means that has to be so to get x alone, you have to do what?
Why do you want to get x?
Because this is x alone. No, not x alone, but square root of x.
Yeah. So
Yeah.
you just what do you?
So what you would do is just have u plus square. Oh wait.
Yeah.
Yeah. Well. 2. No, that doesn't work.
So you had u equals to 2 minus root x.
Yeah.
So how do you get root x? You just rearrange this equation, right? We want root x on the other side, and you on the opposite side.
Yeah.
So you change, you put the minus root x to the left, and then you put the u to the right. Yeah.
Right.
So you get that one. And what is the other thing you need to change?
Oh, because we need to change the integration of them.
So not yet. So
No?
that one we do it in the last. So you change the u, you change the bottom, and then you change the top. What other thing you haven't changed?
The du.
Yeah, the dx.
The
So you need to find a way to change the
yeah.
dx into du.
So dx needs to be equal to du, and if
Is dx equal to du?
no, it is
So, but you need to find what is dx in terms of u.
yeah.
Right? How do you find it?
Which is
So the way to do this is by differentiating the u. So with respect to x. So you have a function u minus root square x. Sorry, the root of x is equal to.
So that just disappears because.
Okay, so
Oh wait, no, it doesn't disappear.
so you've changed this fraction. So now you have I is equal to the integration from 1 to 0. 2 minus u divided by u dx. Now you need to change the dx as well, right? Because you have du here. The way to do this is you had this function, and you want to differentiate this du over dx. What do you get? What is du over dx?
Well, differentiate that 2 to the power of 2 times 1.
So this is 2 minus x to the power of 9. So this disappears, right?
Yeah, and then it's just
half x to the power of minus half. Right. So what is dx?
Dx will be equal to
du divided by this thing, right?
Yeah.
Which is 1 times. So this is the inverse. Times 2, and then times 1 over x to the power minus 1 over half. 1 over 2, so which is just x to the power of half.
Yeah.
So this is dx. Now you need to, so you already worked out that root x is equal to 2 over u. So this one is just equal to 2 over u.
Okay.
Yeah, so this is equal to minus du times 2 times 2 minus u.
Yeah.
So can you put everything back together into the equation?
So you mean like just reversing it?
No, like, so we've already that dx is. So what is I now?
So what is I?
Yeah.
So I would have to be equal to well, since we have that, the u is on the bottom, and then that's not straight, it's bottom. And what was the original? It was
So it's yeah.
oh
Yeah.
oh yeah. 2 minus dx. So then you need to just where is it?
So the bottom is u, the top is
u.
2. Yeah.
U, and then times by 2 minus u, and then times again.
Yeah. So
Yeah,
you
2
have
times because there's x there. So it's just another, I guess, 2 times that, and then you add together, so square. Yeah.
So and yeah, so you compare to this one. Yeah. So and the last thing you need to change is the integration limit. How do you change the integration limit?
I don't know.
So originally we had integration from x is equal to 1 to x is equal to 0. Now you need to change u is equal to something x is, and you need to change it to u. Right? So
Okay.
we had the equation is u equals to 2 minus root x, right? So when x is equal to 1, what is u?
Yeah, so then you just, okay.
U is 1.
Yeah.
Yeah.
Just, yeah, well.
So when x is 1, u is equal to 1. When x is 0, what is u?
When x is 0, it's 1.
So when x is 0, u is equal to 2.
Yeah.
So now we was integrating from x is 1 to x is 0. Now we are integrating from u is equal to 2 to u is equal to 1. And then you just write the thing you just worked out inside. Okay,
Can I ask
so
a
now,
question?
yeah.
When you, so beforehand, when I was doing this, I got a minus 2 times. So this
Yeah, I see what you mean. Yeah.
is,
so there's
is
a minus
negative,
sign.
right? Because of the.
Yeah,
But
yeah.
is
you're
it
right.
because we're changing the limits
Yeah.
that
So
that negative becomes a positive?
yeah, so you are right. So yeah, I forgot to do it. So so it's from 1 to 2 and minus. And now the question is, so the answer is from 2 to 1. So by changing this limit, you eliminate this minus sign.
And that becomes positive.
Yeah, so this big, do you know why that is?
Because you have 1 minus 2 and I have 2 minus
Yeah,
2.
so originally you had this integration when u is 1. So we call it maybe big U 1 minus big U 2. This is equal to minus big U 2 minus
Okay.
U1. So you just basically just pull out a negative sign in front.
Yeah.
The last bit, just to integrate this.
So you just
Do you know how to integrate this?
integrate it?
Yeah. I'll write it on another sheet. So integrate 2 minus u squared over u. Do you know how to integrate?
Yeah, I think so. Well, when you integrate, so this is differentiated, right? No, it's integrated.
So you just integrate that
Again.
expression.
So, two bracket 2 minus u bracket squared over u, and then du if you integrate it again. Wait. Just take what's.
So first you expand the expression
Yeah.
on the top.
So that would be u. I would 2 times 2, 4 minus 2u minus 2u minus plus u squared, right?
Yeah.
So u squared minus 4u
Plus u
plus
squared. Yeah.
4.
Plus
Yeah.
and divided by u times by 2.
Yeah, times by 2
Divided
over
by u.
u.
Yeah. U.
That's u.
And what do you do next?
Then you just add the 2 in again.
So you split the fractions, right? You split the fractions by dividing each term by u. So you split it into 3 fractions.
Okay, yeah. So then it's 2u squared over u.
Yeah. Minus
Minus 2 It's cube. U over U plus 4 over 8. Let's do an 8 over U.
Yeah, and then you integrate each of them.
Yeah, and then to integrate. Yeah, I'm just gonna rewrite that like this: 2U squared. Well,
Just calculate what is
2U squared over
U.
a U, and then minus 8U over U plus 8 over U.
Yeah.
And then if you integrate this, it's instead of taking that, it's just multiplying it upwards, right?
Yeah.
So it would be 2U, cubed.
Okay, so
No, that's not.
so
Here we go.
okay. So the first term is you cancel it out. So you integrate to U, which is just U squared.
Yeah.
The second term is 8. What's the integration of 8 du? What is the integration?
Integration of 8, it's so like.
What's the integration of 8 du? What's the integration of 2 dx?
You just need to add 1 to that, so it's
2x.
yeah.
What is the integration of 8 du?
2U.
8 du.
Yeah.
8u.
8U.
Yeah, so plus 8u. What is the integration of 8 over u?
8.
What is the integration of 8 over u du?
It would be 8, right? No.
No, so for 1 over x, the integration of 1 over x, what is the integration of 1 over x? So if you think it is 1, then when you check if your integration is right, is that you differentiate your integrate. Your integration. What is the differentiation of 1?
It's
0, right?
0.
Is it equal
Yeah.
to is it equal to the thing here? No, right? So it's a difference. So which means that the integration of 1 over x is not 1.
Okay.
So the integration of 1 over x is ln x.
Yeah.
So that's just a formula that you need to remember.
Yeah.
You don't need to know why it is, but so the differentiation of, which means that the differentiation of ln x, what is the differentiation of ln x?
Half 1 over.
Yeah, 1 over x.
Yeah.
The integration of 1 over x is ln x. The differentiation of ln x is 1 over x.
Yeah.
So what's the integration of 8 over u du?
8 ln.
Yeah, 8 ln u. So now you have the whole expression u squared plus 8u plus 8 ln u. Yeah.
Yeah.
And you just plug in 1 and 2 and then divide. And then subtract the 2 values. You guys.
Yeah.
Okay. Next question. It's your turn.
Okay.
Yeah. So what other question ask you to do?
Find A and B and then put.
So yeah, so it just asks you to calculate the root square of u.
Yeah. So I'd say I'm going to put the square of A plus bi.
Yeah.
And then I want to get u. So maybe A plus bi.
Yeah.
You're going to get A squared plus 2a and bi squared.
Yeah. What is I squared?
It's going to be -1.
Yeah. So what is plus b squared I squared?
This one.
The last one, the last term. So what is so
Wait.
I squared is -1. So what does
so
this become?
minus
B squared.
yeah.
Yeah.
So now we have okay, a squared minus b squared and 2a
Yeah.
here,
Do you understand why we are doing this?
Yes.
and we have u equal -1, so a squared minus b squared equals -1.
Yeah.
And 2ab is gonna be
Yeah. And then we solve this.
Yeah.
Do you know how to solve? The equation? Oh, sorry. Then go on to the part 2, please.
what is
Lucas.
is it the
Yeah, I think we discussed last time. So the locus is is all the values for this for that which satisfy this equation. So this relation in this relation it says so u is a fixed point, right? Not
Yeah.
because u is equal to that. It says some complex number z. The distance between z. So z can be like z is not fixed. It can be a set of points.
yeah.
So in this equation, it basically says the distance between z and u, which is a fixed point, is 1. So what would that look like? So I have a fixed point and I have some point that has a fixed distance to this point. So you would have a
So
so you would have a circle. So you have a so to draw the u on this Argand diagram, right? You know what is Argand diagram?
like
So-
you have line and then
Yeah. So you have two axes. One is a
real
real number. That one is imaginary. And to find u, you go to negative real number axis and then go to positive. So somewhere here, right?
yeah.
And so that is the distance between u and z is 1. So the circle will look like this. So it crosses the imaginary axis because real axis coordinate for this u is -1. So the distance between z and u is 1. So it crosses with the imaginary axis. And it does not cross with the real axis because this coordinate is larger than one. So it does not go below this. So this is a locus of that. This circle is a locus of that. Okay. And the next part of the question asks you to determine the greatest value of argument z. So what is argument z? What is argument? What is an argument? So if I have a complex number, for example, we call it a maybe. What is argument of a?
Is it not just a tangent equal a?
Yeah. So it is the angle between the complex number a and the positive part of the real axis. So the argument of a is this angle here. So you have a circle of complex number z, and the question asks you to find the greatest value for the argument z, which means we want to find which z has the greatest angle with the real number axis. How would you find it?
You can get
You can write on the pad if you want.
you can find like this point and this point.
Which point? Okay, so you think that point gives you the greatest.
Yeah.
Why do you think that point gives
Oh, like
you? So yeah, so you have a lot of z, right? So the greatest, so this is the angle between, this is the angle between the z and the axis. So which one gives you the greatest angle?
The smallest point on that.
So that one, right?
Yeah.
So this one gives you the greatest angle, right? Because you cannot go any further than this. Okay. So how do you find? How would you find this angle? Let me draw it again. So you have a circle like this, and this one gives you the greatest. How would you find it? So first of all, this is a tangent of this circle, right? So which means that from the center of the circle to this tangent, you have a right angle. Okay. So if we make a triangle like this, yeah, so if we make a triangle like this, and we want to calculate this angle, sorry, we want to calculate this angle here, yeah. So we already know this is 90 degree, and we know this angle, right? Do you know how do we guess this angle?
It's just
So because we know the coordinate of this complex number u, this is 1, this is 4√3.
yeah.
So in this triangle, we can calculate this angle. And only the last part of this whole angle is this angle, right? How do you get this angle?
Can you just take the hypotenuse of the other triangle and then multiply, and then you can take the from the.
So you
know that that's one.
You mean to calculate this one?
Yeah.
Yes, that's right. So you have 1 here,
Yeah.
and you can calculate this line, and you can do the sine, the inverse of sine, to calculate this angle, and you add this one, that one together. Any questions? No. Who's next?
Questions? So we can split this into this. That's 4. And then
You all know how to calculate partial fractions, I assume.
so then you have
And just by equating the coefficient.
yeah,
And I'll tell you, you get A is 3, B is -1, and C is -2.
B equals, sorry, what?
-1. C is equal to -2. So the second part.
Second part, you have 3 2x -1 plus minus x minus 2 times x2 plus 4 -1. And for this now, I can use the binomial, one of the binomial expansion formulas, but I need to make that 1. So I can have 1 plus minus 2x, and I'm dividing this by 3.
Mhm.
Minus
You know how to do the binomial expansion?
I think so.
Yeah.
Yeah. Okay.
And is this 9?
So you pull out a 3 in front. Can I have the?
Yeah.
Okay. So you pull out a 3 in front, so it becomes 3 to the power minus 1. Right. So inside the bracket it becomes
Oh, yeah.
3 times 1 minus 2 over 3x, and then this 3 becomes 3 to the power minus 1. So
it's 1.
Yeah.
So, yeah, okay. What's this, sorry?
I just so 3 to the power minus 1 times 1. And
Oh, okay.
finish.
And then I can use this. So there's a formula,
Yeah.
which I don't know if by heart, but it's something like 1 plus nx. So n is minus 1 and x is this. So I've got plus 2x divided by 3. Plus minus 1.
I think it's easier to use the Taylor series.
Oh,
Do you know the Taylor? Okay.
right.
Let's just continue with it.
The
4x 2 power 9.
Yeah.
And then that all equals.
Oh, you don't need to calculate. It's fine. So what about the next? So
Mhm.
because the question asks you to expand up to x squared, so you first you expand the left hand side, the first term, and then you expand the second term up to x to the power 2, and then you add them up. So how do you expand the second term?
So second term is I can have minus x plus minus 2, and then I'm taking out the 4 to the minus 1, so divide by 4.
Okay.
Equals x power 2 divided by 4 plus 1.
Yeah.
Minus 1. And
Yeah.
then I do the same thing.
Yeah.
And I put
Yeah.
this in as x, and then I times it by this.
Yeah.
And then I add both of those together.
Mm-hmm. And then you find the coefficient for x and coefficient for x.
X and x. Is that okay?
Do you get it? Maybe not.
I think so.
Kind of.
Yeah.
So explain a little bit. So the first question asks you to do the partial fraction, which we already done, and you get. So you split the fractions and you get, and you get 3 over 3 minus 2x plus minus x minus 2 over x squared plus 4. Okay, so the question asks you to expand this, and in terms of like a number plus bx plus cx squared plus something, right?
Mhm.
And you do it by the binomial expansion as we said. So this expression here, so we expand it one term at once. So we first expand this term and then we expand this term and then we add them up.
Right.
Yeah.
Yeah.
You get it now. Okay. So yeah. Question mark.
Aren't you guys gonna do mechanics?
You can stay to do the mechanics if you want.
No, I don't want to do mechanics. But thanks for the invitation. Let's see. Okay. Number 4. Okay, it's plus given that x equals 10. When t is 0, solve the differential equation obtained between x
So this question asks you to solve the differential equation, right? What's the method for solving differential equation? So you have the differential equation here.
Yeah,
What is a general method for solving the differential equation?
the chain rule.
So you put all the x at one side and all the t at the other side.
Oh, yeah.
You separate the variables. So how do you separate the variables? So what are the variables here?
So dx by dt is equal to x e minus t, right?
Yeah.
Over k plus e minus t.
Yeah.
So then you just times them, so it becomes first becomes dx by times k plus et is equal to x e minus t.
Okay, so
t.
just one moment. So you have, so on the left hand side you have dx
Yeah.
over dt. So you want all the x at left or right?
Yeah,
What do you want? Left or right? Choose one.
I want the one on the left.
Okay, so you want x on the left.
Yeah.
So t on the right.
Yeah.
So you want, in the other word, you want to move all the x from the right hand side to
Yeah.
the left hand side. So what x? What which terms have x on the right hand side?
The xe divided to the power of t, so then you
Yeah,
divide
so
by x there.
there's only one x on the right hand side, right?
Yeah,
So how do you move the x from the right to the left?
divide by x.
So you divide everything by x, and then you, on the right hand side you only have t, right?
Yeah.
And
Even
on the left hand side, which terms have t?
e to the power of negative t.
No, on the left hand side. Oh, sorry, not your equation, but the original equation.
Dt.
dt. So you just move the dt to the right?
Oh, yeah.
So
that makes
can you-
sense.
Do it again.
So dx divided by x,
Yeah.
is equal to e to the negative t over k plus e to the negative t
dt.
dt.
Yeah. So now you've separated the variables.
Yeah.
And what's the next? What's the next step?
Set x to equal to 10.
The next step is to do the integration. Right. So the first step is to separate the variables. The second step is to do the integration. Yeah. So we've completed the first step. Now we need to do the integration.
Yeah.
So what is the integration on the left hand side?
So dx, integrating dx.
So wow. So
Yeah.
this is, what is the integration of that?
Well, it's ln.
Yeah, ln x. What is the integration of that? Which is slightly more difficult.
Yeah, it becomes, well, so I'm gonna say.
So if you think e to the power minus tx as a variable,
Yeah. So it's gonna be negative 2t? No.
so if you think this as a variable, so if you, there's a way you need to think it like backwards. So
divide.
so if you had a function like this, right, and then you differentiate, what do you get?
You'd get,
So you differentiate the inside first, which you get minus e to the minus t times 1 over k plus. That's really similar to this, right? So the integration of this would be something like that.
Yeah.
So that is equal to, because you have a minus here in front, so you need to put a minus as well. So it's equal to minus ln k plus e. So if you differentiate this, you get that time. So you get minus 1 times minus that, and you get the same as this. So
yeah.
do you understand? Okay. So now the equation has become ln x, and don't forget the constant.
Yeah.
Equals minus ln k plus e to the power minus t. Okay, so what is the final step?
You plug in x.
Yeah,
and
so
t,
you
right?
plug in x is equal to 10 and t equals to 0.
So ln of 10 is
plus,
plus c.
so you do this
Yeah.
because you want to calculate this c is equal to
Negative L and of k plus
Yeah.
e to the negative 0,
which
so
is
1.
yeah. So
Ah,
c is
yeah.
equal to
K, yeah.
c is equal to ln 10. What is c?
C is equal to ln of minus 10.
Ln. So it is you just put
Yeah.
10, yeah. Okay, plus 1 minus
Yeah.
ln 10, right? This
Yeah.
is c. And now you have the, how do you do the second question? The second question.
Can you just like plug in to the equation the ln x plus c that you already have?
Yeah, and then you calculate k.
Yeah.
Because k is the only unknown left.
Yeah.
And the question 3 never reach. So question 3, and after question 2 you get the expression which is you get
X is
you get ln x minus ln 10 is equal to minus ln k plus e to the minus t plus ln k plus 1. I mean, so that k is a constant, right? So basically the question says it never reaches 48, means and so no matter how large t becomes, so when t is very, very large, what is t to the power minus t?
Sorry.
So when t is very large,
Yeah.
what is this number?
Oh. Small.
Yeah, so how does it, is there a value it produces over?
Sorry.
So what
It
is
produces a decimal, does
so if you draw the graph of the t
yeah.
to the power minus t, you get something like this, right?
Yeah.
So when t is very large, this function approaches 0.
Yeah.
So when t it becomes very large, this becomes very small, which is almost 0.
Mm-hmm.
So now the function becomes ln x minus ln 10 equals minus ln k plus ln k plus 1, right? Because the limit for this value is 0. So if we rearrange the equation, it becomes ln x is equal to minus ln k plus ln k plus 1 plus ln 10. So as you can see at the right hand side, it is a constant because k is a value which we didn't calculate, but k has some value. And on the right hand side is a constant, which means x is also a constant. So which means when t is very, very large, x reaches a constant value. And if you calculate k, you get this as ln 48. So which means when t is very, very large, x reaches the limit of 48. Do you have any question for this one? Kind of. You understand? Last one.
Should I write down here or?
Just tell us how would you solve the question?
So first I'm gonna find the direction vector of AB, and then you can get equation.
Yeah, what is the equation for the line?
I
AB.
it's it's gonna be.
So how do you get the directional vector?
So you just need to minus it.
Yeah, minus a by b.
Yeah.
And
And then
what is the general equation for the line?
that one. What do you mean?
So what is the general equation for the line? What is the equation
Oh,
for the
so
line?
you put like random points.
Yeah.
Plus
On the line plus
On
the
the line.
directional vector
Yeah.
times. Yeah. So and then what's the next step?
And if J vector is an intersect, that means if you times it, you can get 0.
Okay. So
So
if two lines intersect, then you can equate the two lines, and if you have a solution, then it means they intersect,
Yeah.
right? If you cannot find a solution, that means they don't
Yeah.
intersect.
Mhm.
Yeah. So first you work out the. So first you work out. You have a equation of line here. So this is line 1, and first you work out the equation for line 2, which is just a random point on the line. Maybe we can say A, because A is on the line AB,
Yeah.
right? Plus a directional vector times a constant, plus a directional vector times a constant. The directional vector is just A, B minus A, right? And you equate line A and to line B, and you find if you can, and you try to find a solution for mu and lambda. If you can find a solution, then yes, they intersect, because when they are equal, they intersect. If you cannot find a solution, then it means they don't intersect.
Yeah.
So question I, how do you find the equation of a plane? So you have a plane, and the question tells you that the line L is on the plane and also the point A. How do you find?
You can set up simultaneous equations. So, for example, you could have the general equation of a plane will be r times the normal vector equals d.
Okay, do you want a pad?
So your general equation, where is this?
That's awesome.
Okay. General equation would be r times equals d. And so then you can, for example, put in a point that's on the line, like A times n
Okay, okay, and then you work out D.
equals d, and then you can also have this point because that's also on the line. So 1, 1, 2 times n equals d, and then you can have the normal vector crossed by any directional vector, which you have here, and that should equal 0. So you have 0 times the directional vector of L. And then, so you can, if you solve these, you'll get a ratio. And so, for example, that you solve first and you get a value for, let's say, A.
Okay, let's just go back to the general equation for the plane. So you have a point on the plane times a normal vector is equal to some distance d. So for the point on the plane, we already know is A, right?
Yeah.
Or any other point. How do you find the normal vector?
So the normal vector you can find by then equating these. If you have, for example, so I'm gonna, do you want me to work it out?
No, it's fine. Yeah.
So if I have I'll have 2A
Okay, I see what you mean. Yeah.
minus B plus 3C
Yeah.
equals D, and then I can find.
Okay, and then solve the equation.
Yeah.
Do you know?
Yeah.
Okay. I think there's an easier way to work out the normal vector. So basically, you have the plane like this, and if you find, so you have a random, so you have a vector on the plane you already know, which is a directional vector of this line. And if you find another vector and you do the cross product, do you know what a cross product is? So basically, a cross product of two vectors is you have another vector which is perpendicular to both. So if you cross this vector with another vector, and you get a vector which is the normal vector to the plane. So it's easier to get. And then you get this normal vector, and you plug it into the equation of plane. And this point already know, and this point you just worked out, and you do the dot product, you get a number which is d, and then you know the equation of plane.
Yep.
Okay. Okay. Any questions? Any questions?
Good luck in mechanics.
Can we just find this expression?
Yeah. See you later, guys.
See you next week.
Bye. Do you have the mechanics book?
Do I have it? I don't think I have it. No. I don't have it with me. Do you need it?
Oh no, it just we need to do it later on. I can't find it in the laptop.
Oh, what about if you go to the third tab?
Sorry.
The third, yeah. No,
Down.
down? No, yeah, that one. Is that
Is
right?
this? No, it's not. Oh yeah, it is the mechanics. Yeah. I don't think we have time for all of the questions.
I don't think so. We're gonna have to.
Probably just 2 or 3 questions. Which we got like half an hour maybe. Yeah. So the first question. Do you want to tell me what you think?
So
So for the mechanics questions, it's always best if you start by drawing the diagram.
So this is our background. Particles. So this is being projected by, let's say, theta. U is 12 s. This is equal to v sine theta. This is u sine, u cos theta. And time equals 1.6 seconds. So I can do stuff now. And I can calculate the angle of projection. So I know that if I look at the horizontal component.
So what determines the time for it to drop down to the ground?
So the time, what? Sorry?
So what determines the time for it to drop down to the ground?
It's speed and it's mass. And
Yeah, so is it horizontal or vertical? So does it matter what speed you have for the vertical direction? Sorry, does it matter what speed you have for the horizontal direction?
No.
So, for example, if I had a faster speed for the horizontal direction, but the same speed for the vertical, would the time for it to drop back down to the ground the same? Will you have the same time? Like, for example, if you have a faster or slower horizontal speed, would it matter?
No.
Yeah, so no, it wouldn't.
Because it's not.
Yeah, because the horizontal and vertical direction are independent. Right? You can think of it as independent. So the time for it to drop to the ground at the ground is just purely the vertical speed. So you can't just ignore the horizontal speed, and you just think of it as a simple one-dimensional motion.
So if we have, if I use v sine theta, I use the equation v equals
V vertical is equal
u plus 80. Is that it?
Yeah, you can do that.
Then v sine theta equals 12 sine theta. Sorry, this is a different angle. No.
Yeah. So let's just think about this motion, right? And yeah, as I said, so the horizontal speed does not matter. It's only the vertical speed. So for example, if I throw something upwards, at this point I have a initial speed which is 12 times sine theta, right?
Yeah.
What about at the top? So if the motion of the ball goes from this and goes to the top and then drop down, right? So what is the speed at the top?
0.
Yeah, so if you look at this equation here, the u is, what is u?
U is 12 sine theta.
Yeah, what is v?
0.
Yeah, so you can, and then plus 80.
Minus 10 times 1.6.
Yeah.
And then I can find theta.
Is it 1.6?
1.6 seconds, isn't it?
Yeah, but 1.6.
No, so it'll be 0.8.
Yeah. So that's the first question. Second question.
Okay. So I've got, I'm guessing I'm going to be taking moments. And angle center of mass around between 7 plus magnitude 10. Okay. Okay, so I'm going to split them into vertical and horizontal components. And
So
upwards and downwards.
So you read the question. You already
Yeah.
read it. Okay. So the first question asks you to calculate C-class. As you said, so you should take the moment. Which about which point?
About point A.
Yeah. So what are the forces that's acting on the rod that is causing a moment?
So we have the weight.
Yeah.
And we have this.
Yeah. So how do you calculate the moment?
So
Hello.
You kept it running, or you use a new one?
I think it's still running. It's not new ones.
Okay, it's fine. We'll just add it. We'll edit the tag later to say it's both of those two papers.
Yeah.
Yeah.
yeah, so this, and I need to get it in the perpendicular direction, right? And then times the distance.
How do you calculate the moment? Force times distance.
Yeah.
So what is the distance between the 6 Newton force and the point?
0.8 and
Is it the distance? Is it 0.8 the distance between the force?
between the 6 Newton and A.
Yeah, you think it's 0.8.
Well, that's not the perpendicular distance.
Yeah.
So that would be the perpendicular distance.
For a moment, force times distance, and the distance is the perpendicular distance.
Okay, so this equals sine theta times theta. So we've got 0.8 sine theta times 6. And then you have this distance, which is
What? Okay, so is this the distance between that force and and the A? You think this is the distance between the 10 Newton force and A? So the distance is always the shortest distance, right? Is there a shortest distance between this force and point A than that? Do you think?
I'm guessing no.
Okay, so normally the way we find the distance is that you extend this line. And then find the perpendicular distance between point A and this line. Right?
Okay.
What is the perpendicular for?
That line.
Is this one. Right?
Yeah.
This is the distance between the force and the point. For example, the same goes for that. So you extend this line all the way up and down, and you find the perpendicular distance between A and this point, which is that one. It's the same as this one you did.
Okay.
But yeah. So this is how you find the distance.
So we can.
So how do you calculate the perpendicular distance between A and the force?
You'd have this angle.
Yeah.
Which is, so that's a right angle.
Yeah.
So this angle is theta minus 30.
Yeah.
And then I take the sine of that.
Yeah.
So sine theta minus 30. And I times it by
so you want to find this distance here, and so you got the angle here. So sine, what is the long edge, length of the long edge?
this one.
So sine of this angle times the distance times the length of the long edge gives you the length of the short edge.
There we go.
Yeah.
Okay. Then times the force.
Yeah, then times force. And
10
yeah.
newtons.
And those two moments are equal, right? Because it's in equilibrium. And then you just solve the equation. Okay. Second part of the question.
So, equation fiction. So you'll have mu which is the coefficient of friction,
Mhm.
times. So all the equilibrium. So all of the contact force.
So what is how do you calculate the coefficient? The coefficient of friction
So
in
the
general?
mu times n.
Yeah. So for example, because we are calculating the coefficient of friction at the wall, right?
Mm-hmm.
So at the wall here, you have you can split it into two forces. One is a vertical force, and the other one is so if you look at the wall as like a ground, so yeah, so a force which is perpendicular to the wall and a force which is parallel to the wall, right? So we call this one F, and maybe this one F P. Okay, so the coefficient of friction mu is equal to the ratio between Fn and Fp. Right? This is the definition for the coefficient of friction. It's just like when you have something on the ground, and the coefficient of friction is equal to the friction force divided. Sorry, it's the other way around. Yeah. So no. So yeah. So it is the supporting the reaction force divided by the friction.
That makes sense.
Yeah.
So friction times mu is equal to the
Yeah.
reaction force.
So that's the definition. So how do we find those two forces?
So we can find them using our other forces. So
Yeah.
you've got 10,
Mhm.
and you can do you've got this. You can get that line next to 30 degrees. So if you do 10 cos 30.
Let me see. So maybe it's the other way around actually. Okay, so anyway, so yeah, so you divide, so you
Wouldn't it
Yeah.
be 10 cos 30 divided by?
yeah, so you split it into vertical and horizontal direction, right? So this is 6, and it's just you don't need to do this because it's already vertical. So that one is cos 30 degree times 10. This one is sine 30 degree times 10, right? So this force here is equal to that force here, right? Because the net force is in equilibrium, so the net force is 0. So essentially this one is equal to sine 30 times 10, and that one is equal to
Cos 30 times.
cos 30 times 10. But you also have a weight here, which pulling it
So
downwards.
cos 30 times 10 plus minus 6.
Yeah, so cos 30 times 10 minus 6 is equal to that force. Yeah. So mu is basically equal to, yes, is the other way around. So Fp over Fn. So it is equal to the friction force over the reaction force. So yeah, it is equal. So the coefficient of friction is equal to the friction force over the reaction force. So the friction force here is this way, which is Fp, which is equal to 10 sine cos 30 degree minus 6, and the reaction force is equal to sine 30 times 10, and this number is contracted. Okay, maybe we do one more question.
Okay. So the natural length equals 0.8. So that's 4 Newton.
Yeah.
Meters. 16 mass equals 0.4. So you can use the formula. The tension working in this direction. You can use the formula is length. So tangent is equal to weight right now because
Yeah,
we're having
yeah, that's only force acting on the
so
screen.
you've got extension. Oh no, this divided by L. And so if you've got 4 times 0.8 divided by 16 will give you 0.2, I'm guessing.
Question 2.
Okay. So if equate energy at the start, I have kinetic energy of 0. I'm going to end with 1p squared 2.
At the start, you have kinetic energy 0. So it's you project it vertically downwards and until it reaches speed of 0. So
I'm going to have the other way around.
Yeah.
Sorry. Okay, never mind. So this is that, and that's U. Then
so U is a
Is the-
thing you want to calculate.
then
And what other energy you
calculate
have?
speed. Then I have elastic potential
Yeah.
energy. So at the start, that's 0. And
Okay, is it 0 at start? So as 0 means the line is the string is at its natural length, but was it at its natural length?
no, it had an extension
Yeah.
too.
So
So now
so even at the start you had
you have
that's it.
2 x. Is that the equation for energy?
Yeah. So x is okay. So what does x stand for?
X is the extension.
Yeah. So yeah, that's right. That's the equation.
And then at the end, if it's at rest, we will have at 1.4. So we'll also have,
Elastic potential.
but we'll
energy.
have a new extension.
Yeah.
So, and then you have MGH.
So we can say at the start is 0. Oh, no,
Yeah.
sorry. So we can say at the end is 0 because it's always relative. As MGH, the H is just the height difference. So you know this, you know the extensions, and you know the H.
equate this to
And you
this, and I
can,
can find
so
out what U
yeah,
is.
so U is the only variable here. The last one.
So the string becomes slack. This is the instant. Most when it's going up. So
again, you use you
Energies.
equate the energy, yeah.
this time though we'll have at
So-
the end.
Yeah, so this will become the start of that.
Yeah, so that, and at the end we'll have 0
Yeah.
here, and we'll have MGH, and we'll have will we have 0 here too? No, we will have
Yeah, so find speed of P, so which
P
means
squared.
there must be a speed.
2, and
Yeah.
then I can equate
Yeah.
it and find P.
Okay. Do you want to do more? Okay. Let's just finish here. Maybe.
Sorry,
Just finish here, yeah.
Thank you.